Hello everyone, welcome back to the revision series of UGC NET Electronic Science. So in this video we are going to learn about synchronous counters. Okay, synchronous counters. This concept we'll see in this video. If you are first time to my channel, please consider subscribing and don't forget to click the bell icon to get video notifications from my channel. Right, so we have already seen asynchronous counters, right? So in asynchronous counters all the flip-flops are not triggered simultaneously and output of flip-flop is given as clock input of next higher order flip-flop. This point you should remember, right? So throughout. So in synchronous counters all the flip-flops are triggered simultaneously, that is all the flip-flops are clocked with clock pulse simultaneously. Okay, so all the flip-flops will be in on state simultaneously. That is why it is called as synchronous operation or synchronized with respect to clock. Every flip-flop will be in on state at the same time. So that is why if you see the arrangement here, so if you see the arrangement here, this is the clock pulse which I have given. So this clock pulse is given and it is also given to the second flip-flop. And if in the 3-bit synchronous counter also, so same clock pulse is given here, right? So triggered here and also given here also. In the third flip-flop also it has been given. Okay, right? So that is the thing. And the operation wise also, suppose this is 2-bit, right? And this is 3-bit and this is also 3-bit. Okay, I'll tell you the difference. So this is 2-bit asynchronous counter, clock pulse is directly given here, right? No condition is there since JA and KA both are connected to high. This is again your LSB bit and this is your MSB bit because only 2 bits are there. So again condition will be same, QB QA only, QB QA only, right? As we have seen in asynchronous counters, right? So clock pulse initially both the flip-flops are cleared since J is equal to K is equal to 1, so LSB bit changes its state continuously, right? 0 1 0 1 0 light. Okay, and if you see here JB same functionality. So in the 2-bit asynchronous counter also we have seen that QB changes its state only when QA is equal to 1. This is for 2-bit, and for 2-bit, so here QB changes its state when QA is equal to 1. Similarly, QC changes its state when first flip-flop triggers the second flip-flop and second flip-flop triggers the third flip-flop. The condition will be QA is equal to QB is equal to 1. So the same conditions both in the case of synchronous and asynchronous counter, but they are achieved in different way. The conditions will be same, but the achievement of that conditions will be in different way. So there we are using the clock pulse, but here we are using this direct output is given as input here. So the output QA is given as input to JB and KB. So JB and KB, in order to be in toggle mode, this must be equal to 1, yes or no? So when J is equal to K is equal to 1 only, the flip-flop changes its states. Qn plus 1 is equal to Qn bar. So in order to be this 1, then QA must always be 1. That means in order for B to change its state, always QA must be equal to 1. Same condition as we have seen in asynchronous counters, but the achievement, the method of achievement is different. Okay, same condition. So 0 here does not changes its state because it will not be in toggle mode. It will not be in toggle mode, so it will continue its state. So 1 is occurring here, so it will change its state. 0 occurs here, so continues in the same state. 1 occur here, again it will be in. So the next state of 1 1 is 0 0, so counter resets. So again 0 0 0 1 1 0 1 1. So totally 4 states again. Okay, counter counts from 0 to 3, that is 0 to 2 power n minus 1, so 2 power n states totally. That's all. That means 4 states are there, so it is modulus number is equal to 4. That's all. Okay, same for 3-bit counter also it will be same. So clock pulse is directly given and JA and KA are connected to high. J and K are connected to high. So clock pulse are given to each and every flip-flop, so all flip-flops are triggered simultaneously, right? So the operation will be same, QC, QB, QA. So QA directly clock pulse is given and J is equal to K is equal to 1. No condition is there for LSB bit. So this is your LSB bit and this is your MSB bit. So no condition is there, so it will continuously changes its state. Okay, then QB, in order for QB to toggle, that is QB to toggle, this must be equal to 1 because JB and KB are tied together. So in order to get this as 1, so QA must be equal to 1. So when QA is equal to 1, it changes its state. So initially all the flip-flops are cleared. So here the value of QA is 0, so it will continues in the same state, and here it is 1, so it will change its state. 0 again continues in the same state. So 1 is triggered here, so it will change its state to 0. Okay, so continues its state because it is 0. So 1 is occurring, so it will change to 1. Because 0 is occurring, it will change. Sorry, it will continue in the same state. So 1 is occurring, it will be 0 here, same as the previous case. Okay, and QC is equal, so this should be equal to 1. So this is equal to QB and this is QA. From here we have taken, right? So from here we have taken, so this input is QA, QB. So output of AND gate is 1. Output of AND gate is 1 only when both the inputs are 1. So in order for the MSB bit, that is the C flip-flop to toggle, JC and KC should be equal to 1. So that means output of AND gate should be equal to 1, and output of AND gate is equal to 1 when both the inputs are 1. So that means QA must be equal to 1 and QB must be equal to 1. Same condition as we have seen in the case of asynchronous counter, but the achievement is different, right? So we'll get 0, 0, 0. So here both are 1s, so it will toggle, and again here both are 1s, so it will be 0. So 1, 1, 1, next state is 0, 0, 0, so it will be reset. So it will count from 0, 0, 0 to 1, 1, 1, that is from 0 to 7. So total number of states is 8. So it is 3-bit counter. So this is a mod 8 counter. So modulus number is 8. Okay, so modulus number represents the total number of states. Remember that. Okay, so this type of counter, this is also 3-bit synchronous counter only, because synchronous, if you are given with a counter and asked to find whether it is synchronous or not, just synchronous or asynchronous, just see the clock pulse. If clock pulse is given simultaneously to all the flip-flops, if the clock pulse is given simultaneously to all the flip-flops, then it is obviously a synchronous counter. If the output of first flip-flop is given as clock input of the second flip-flop, output of second flip-flop is given as clock input of the third flip-flop, then it is asynchronous counter. Okay, simple in operation, right? So here propagation delay is more, so here we are giving directly here QA value. So whatever QA you have obtained here, so if you make some arrangement manually and give the value here, so that type of counter is called as parallel carry counter. Parallel carry counter. And this counter is called as serial carry counter. Serial carry counter. So all the conditions will be same, serial carry counter, and this is parallel carry counter. The conditions will be same. So in order for JC and KC to be 1, so QA and QB must be equal to 1. So this should be 1 and this should be 1. So instead of taking from here, right? So instead of taking from here, because due to propagation delay, so instead of taking from here, we are taking directly here. Okay, so that is why it is called as parallel carry. So whatever the output you have obtained here, you are giving here manually in the case of parallel carry counter. So that time period decreases. Okay, so this is about synchronous counter. I hope you have understood this, and if you have any doubts, please comment in the comment section. I'll clear all your doubts. Okay.